Hello students, welcome to today's Object-Oriented Software Engineering class. In this session, we will learn about UML Modeling and Architecture, one of the most important topics in software engineering and object-oriented system design. In today's class, we'll discuss on the introduction to UML, UML models, UML structure which contains basic building blocks, common mechanisms and UML architecture. By the end of this session, you will understand how UML helps software engineers to visualize and design complex software systems. UML stands for Unified Modeling Language. It is a standard visual modeling language which is used to represent the structure and behavior of software systems. It is important to remember that it is not a software development process. Instead, it is a modeling language that supports different software development methodologies and it's commonly implemented using case tools. UML mainly consists of two categories of models, namely static model and dynamic model. The static model describes the structure of the system, including classes, objects and their relationships, whereas the dynamic model explains how these objects interact and change their states while the software is executing. Both models together provide a complete understanding of the software system. UML structure. UML structure contains building blocks. These are the basic UML modeling elements, relationship and diagrams. Common mechanisms which provides common ways to achieve specific goals, and UML architecture which is UML view of the system architecture. The UML building blocks is built on three fundamental concepts such as things, relationships and diagrams. Things represent the various modeling elements used in UML. These include structural things like classes and interfaces, behavioral things like interaction and state machines, grouping things such as packages and annotational elements like nodes. Relationship define how different modeling elements are connected together. Common relationship includes association, dependency, generalization and realization. Finally, diagrams provide graphical views of the software system, helping developers to understand both the analysis and design aspects of the project. There are three static diagrams such as class diagram, component diagram and deployment diagram, and similarly 6 dynamic diagrams such as object diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram and activity diagram. To make UML models more expensive, 4 common mechanisms are used. The first is specification. Next, adornments. The third mechanism is common division, and finally extensibility. In specifications, every graphical symbol has a corresponding textual description. For example, the UML model for the class bank account can be represented using a class notation or use case notation by using dependency relationship. So this part of the diagram is called as graphical dimension, and its corresponding textual dimension is presented in the next part of the picture. Adornments allow additional details to be gradually added to the UML symbols. The first part of the diagram you can see the class window is represented without using any adornments. But in the next part of the diagram you can see the class window is represented using the complete details. So such additional details which is used to explain the diagram is called as adornments. The third mechanism is called as common divisions, such as classifier versus instances, interfaces versus implementation. This helps to distinguish between abstract components and their actual implementation. Fourth mechanism is extensibility, where UML can be customized using constraints, stereotypes and tagged values to meet specific project requirements. UML architecture provides different views of a software system so that developers can understand it from multiple perspectives. The 5 important views are logical view, which focuses on classes and objects, process view, which represents process and threads, implementation view, which describes the software components, deployment view, which shows how software is deployed on the hardware, and finally use case view, which captures the user requirements and serves as a foundation for all the other above said views. Together, these views help software engineers to build well organized and maintainable software. From a placement perspective, UML is one of the most frequently asked topics in software engineering interviews. Companies often ask candidates to identify UML diagrams, explain relationships such as association, dependency, and inheritance, or choose appropriate UML diagrams for the given scenario. A solid understanding of UML is also essential for system design rounds, software developer interviews, and finally a project development. To summarize, in today's session, we have introduced the UML as a standard visual modeling language, explored various models, building blocks, common mechanism and its architecture. These components form the foundation for the UML diagrams that we will study in the upcoming classes. Thank you all and see you in the next lecture.